All right, here's the examples for the test examples for target 5, which is on finding the vertex of a quadratic equation. So the first thing you have to do for each of these is identify which form the equation is in. So this first one is in vertex form. The second one is in standard form. And the third one is in intercept form. So to find the vertex in standard form, you're basically just looking for the HK. So if I were to change this x plus 2 to x minus a negative 2, and the minus 5 to plus a negative 5, which is just using the definition of subtraction, you can see that the h is negative 2 and the k is negative 5. When it's in standard form, like part B, the x-coordinate of the vertex is negative b over 2a. So in this case, b is a negative 7, and a is negative 3. So my x-coordinate of the vertex is going to be negative 7 over 2 times negative 3. So that'd be 7 over negative 6, or negative 7/6. And then to get the y-coordinate, you just use the equation, because the equation tells you how to find y. So I'm going to take negative 7/6, and I'm going to store that as my x variable. And now I can type in the equation, and the calculator will know to use negative 7/6 as x. And this way I'm not rounding off that decimal. Notice the use of negatives too. It's negative 3 times x squared minus 7x plus 5. And if I want a decimal, I can now convert that, or excuse me, if I want a fraction, I can convert that back to a fraction. So the y-coordinate is 109/12. And for part C, when it's in intercept form, we're referring to the x and y intercepts. So the x-coordinate of the vertex is going to be the average of the x-intercepts. So the x-intercepts, if I change these to minus and negative, are going to be negative 4 and negative 6. Those are the zeros of this quadratic equation. They're the values that make each factor 0. So if I add negative 4 and negative 6 together and divide by 2, you're going to get negative 5. And then again, to get the y-coordinate, you just use the equation. So I'm going to plug negative 5 in place of both x's here and here. So negative 5 plus 4 times negative 5 plus 6. So that would be negative 1 times positive 1, which is negative 1. Same idea for number 2, state the x-intercepts. So the x-intercepts are going to be the 2 points where this graph would cross the x-axis, which are the zeros of this equation. So negative 4 would make the first factor 0, positive 6 would make the second factor 0. You're basically just solving these factors equal to 0. And then the vertex is going to be the average of those. So if I add negative 4 and 6 and divide by 2, I get 1. Negative 4 plus 6 is 2, divided by 2 is 1. And then if I plug 1 in place of the x's, I get negative 5 times negative 5. So negative 5 times negative 5 is a positive 25. For number 3, writing the equation in vertex form. So that's, again, this form. Subtracting h from x translates or slides the parabola h units to the right. And adding k translates it k units up. If it was a plus a number, then it'd move it left. If it was a minus number here, it'd move it down. So my h and my k are right here. So my equation is going to be a, I don't know a yet, times x minus h, the quantity squared, plus k. So now to find my a value, I use the point that it passes through. That's my x and y coordinate. So y is negative 5 when x is 1. So I get negative 5 equals a times 1 minus 2 is negative 1, squared is positive 1. And if I finish solving this equation for a, I'm going to add 3 to both sides, and you get a is negative 2. So the final answer is negative 2 times x minus 2 squared minus 3, or plus negative 3. Number 4 is just an application of finding the vertex, because if you think about what the graph would look like for the height of an object over time, so what this equation tells us right here, this is the initial height. So at 0 seconds, this ball starts at 2 meters above the ground, and it's just going to go up and down and come down. So this point would be the x-intercept, or the root at the end. And then what they're asking is, what is the maximum height, and when does that occur? So we want to find the vertex. This number, by the way, is the initial velocity, so it's 32 meters per second. And this is gravity. It's actually half of acceleration due to gravity, half of negative 9.8 meters per second squared. So to find the vertex, the x-coordinate, I'm just going to do the negative b over 2a. Negative 32 over 2 times negative 4.9. So that's going to give me my x-coordinate. I'm going to have to put the 2 times 4.9 in parentheses. So I end up dividing by all of that, not just the 2. So that's the x-coordinate of the vertex. .2, we'll just round it to 7. And then, rather than use that rounded answer to get the y-coordinate, I'm just going to, again, use the last answer function or store that as x. So negative 4.9 times that answer squared plus 32 times that answer plus 2. So I'm just plugging that 3.265306 into the equation. And that's 54.24. So the maximum height is 54.24 meters, and the time at which it happens is 3.27 seconds after it was thrown. And the last one for this target would be completing the square to find the vertex. So to complete the square, you're basically going to try to get this in vertex form. So the first thing you do is you factor out any leading coefficients from the first 2 terms, the x squared term and the x term. So if I factor out the 2, I'd be left with x squared minus 14x. Then what I'm going to do is I'm going to leave some space to complete the square. And then I'm going to put the plus 102. So the idea here is we want to make this a perfect square. Thinking visually, we have x squared and a negative 14x to work with. So if I want to make a perfect square, I'm going to split that negative 14x in half. So if you take half of negative 14x, you get negative 7x. That's going to ensure this is a square. The dimensions of the square would be x minus 7 by x minus 7. So to complete the square, we're missing this part, which is negative 7 times negative 7, or positive 49. So I'm going to put a 49 here to complete the square. But then that 49 was not in the original problem, so I'm going to subtract 49 over here to balance it. However, then I remember that this 49 I added actually gets doubled because of that 2, so I'm going to subtract double 49 to balance it. And then the whole idea is that this part right here can be rewritten as x minus 7 times x minus 7. Just a visual display over here that shows x squared minus 14x plus 49 is equal to x minus 7 times x minus 7. And that's where we get into that vertex form. And then the other part, 102 minus 98 is 4. So there's our vertex form. So then the vertex is the point HK.